Okay, good morning class.
Good morning, sir.
So at this point we trying to wrap up Euclidean geometry. As you know, we're a couple of lessons behind. 6 lessons behind. How many lessons are we behind? More than 6. What was your homework? 9.8. 9.8. But I must still add answer 9.7. Is that correct? Hello?
Yes, sir.
Where are we answering now from? Why did I cut number 8? Exercise 9.7, number 8. Did I have to answer this question? Okay. So let's do this quickly. Okay, so in 9.7, on page 319, we are told two circles intersect at G and E. Then we are told that CDP is a tangent to the larger circle at D. So if that's a tangent, what do we know? We know that D4 is equal to G3. Not so? And we know that that angle is equal to that angle, and so on and so on. Okay. And this whole angle here, D2 and D1 is going to be equal to F and so on. Okay. Then we are told that this thing highlighting this box. Okay. So then we are told that CPD is a tangent to the large circle at D, and DG is a tangent to the smaller circle at G. So this is a tangent. So if this is a tangent, we know that G2 is equal to A2. Why? Tangent theorem. You guys got it? And many other things thereafter. Okay. Then we are told that AED and AGF are double chords, which means to say it's a straight line, a chord in each circle there. AB is produced, which means to say it's extended to C, and GE, so this has to be an E here, is extended to meet that C. Then we are told that BE is drawn. First question, prove that AGF is parallel to CD. So if lines are parallel, what do we know? Alternate angles are equal. Corresponding angles are equal. Coincident angles are supplementary. So as you can see here, there we have that angle already equal to that angle. So the job is already done. Can you see that, people? So what do? We introduce our x. Yes. We introduce our x. Okay, so let D1 equal x. So we say let angle D1 equal x. So if that's equal to x, then we know that G2 is x. Okay, so angle G2 is equal to x. Why? Tan-chord theorem. Okay. Then we know that A2 is x. Why? Also tan-chord theorem. So what do we say now? So now we say so what can we say now? Since angle A2 is equal to angle D1, which is equal to x, therefore AF is parallel to CP or CD. Why? Because the alternate angles are equal. So now I can add those parallel lines in. Even people at this point, if we didn't manage to solve or manage to prove that those lines are parallel, and you're answering B, then you fill in that parallel lines. Because most of the time or sometimes we need those parallel lines to answer B and C and so on. Does that make sense? Also sometimes learners can't manage to prove that the two triangles are similar or congruent. And that was the question, the previous question. You carry on as if you have proven. Okay. So I'm going to take this off so that I can keep the diagram in focus. Okay. Then in B says CD is a tangent. CD is a tangent to the circle through BCE. People, if this was a tangent, what would we have known? That C2 is equal to B1. So in other words, we must prove that C2 is equal to B1. Okay. So now I can bring a Y in. Okay. So you say let C2 equal 1. People, if that is Y, which other angle is Y? G1 is Y. Why? As you can see, alternate angles. Okay. So G1 is Y. We say it's alternate angles with AF being parallel to CP. Can you see why I'm saying that you can use it in the next? We need it for the next one. Okay. What else can be said in from here? That D1 is Y. B1. So why is B1 Y? What do you notice here? Not the O, it's a Y. Exterior angle of cyclic quad equals the interior opposite. Not so? So D1 is Y. Exterior angle of cyclic quad equals the interior opposite angle. Is that not enough to conclude that's a tangent? Yes. So we say, state the obvious. Since C2 is equal to B1, which is equal to 1. Therefore, CD or CP is a tangent to a circle through BEC. Why? Because not the tan chord theorem. Angle between line and chord equals angle in the alternate segment. Angle between line and chord equals the angle in the alternate segment. This is also the converse of the tan chord theorem. Alright. Yes. Yes. You can say converse of tan chord theorem. I didn't want to tell you at this point yet. I want you to first learn that. It's better for you. Okay. But if you have written it, it's fine. It's acceptable reasoning. Okay. And the last one, C. C says, must prove that DG is equal to DF. People, if these lines are equal, then what do we know? We know that G3 is equal to F. So if we can prove that G2 is F, we've done the job. Not so. But what is G3? Sorry, G3 is equal to F. But what is G3 also equal to? Sorry? D4. Right? And D4 is also equal to F. So I'm not going to bring a variable in. So I already got X's and Y's. Alright, so I can just say that G3 is equal to D4. Why? Tan chord theorem. Okay. So you say tan chord. Okay. Then we're saying that D4 is equal to angle F. Why? So alternate angles. With AF being parallel to CP. Now is that not equal? Yes. So we say since angle F is equal to angle G3. Okay, we've proven that. Therefore, GD is equal to DF. Why? So that sides opposite equal lengths. Okay. Any confusion there? Alright. Let's then go on to the next one. So now we look at more complex problems, and this is on page, for example, 1 on page, sorry, 322. So now we are told that alright, so now we are told that E, B, G, F is a cyclic quadrilateral. Okay, so just remember now all cyclic quadrilateral properties are now evident here. Okay. Okay. Then we are told that this here. Then we are told that ABC is a straight line and FG and EB produce meter D. Then we are told that FC is a tangent to the circle at F. So that's a tangent. What do we know? F3 is equal to angle E. Not so. Why? Tan theorem. Then we are told that EF is parallel to BG. EF is parallel to BG. So what do we know from there? We know alternate angles are equal. Corresponding angles are equal and co-interior angles are supplementary. So this angle here is equal to that angle. Okay. Also, it's alternate. Also that angle, this whole angle will be equal to that whole angle, and so on and so on. Okay. Then we are told that angle B3, or what's it, B5, is equal to, B5 is equal to B3. So that will also get the X. Okay, so that those angles are all the same then. B5 is also equal to B1, which is vertically opposite, and as you can see, B1 is also now equal to F1, which now means to say I can prove that ABC is a tangent to the circle at B as well. Okay. Then we are told the first question, prove that BDCF, BDCF is a cyclic. So how do you prove something is cyclic? Exterior angle is equal to the interior opposite. Do we have an exterior angle there? Yes, we have B2. And then the whole angle of C, you can prove that. Or angles opposite angles are supplementary. Equal angles subtended by the same chord. Okay. D, B, D, C, F. Cyclic quad. So we can prove that this angle here, which is F1, is the same as B5. I've done the job. Not so? F1? No. Yeah, F1 and B5. Yeah, it's from this coordinates. CD is subtending that angle, and CD is also subtending that angle. Not so? So if we can prove that if not F1, what is this? F3 is equal to B5, we've done the job. No? So what do? We bring our x into it again. Okay. So we say let B5 equal x. So which other angle is equal to x? Sorry? Angle. Just hang on. Yeah, it's also equal to B3. That was given to us. I think I marked the wrong angle out there. No? I said F3 was equal to angle E. No? That's what I said earlier. I made a mistake there. Because if this is a tangent, then this whole angle, F2 and 3 is equal to E. I made a mistake earlier on, sorry about that. F3 is actually, that's why I'm wasting, losing a lot of time here, is because F3 is actually equal to B3. There's the tan chord here. No? I marked the wrong angle, sorry about that. So we can say that F3 is also equal to x. Why? Tan chord here. There we go. Now it makes sense. Tan chord, no? So now I can state the obvious. We say since angle F3 is equal to angle B3. No. Since angle F3 is equal to angle B5. Right? Can you see here? There's the bow tie or the butterfly. No? So since B5 is equal to F3, which is equal to x, therefore BFCD is a cyclic quad. Why? Because equal angles subtended by same chord, and that's chord DC. Okay, now remember that this is now a cyclic quad. I'm just going to put dots here, which now means to say that we know a circle can be drawn through those chords. Okay, let's look at B. B, we must prove that ABC is a tangent. So ABC is a tangent to circle EBGF. EBGF. Sorry? Yes? ABC is a tangent to the circle EBGF. What's wrong? What are you guys saying? Okay. So, if there's a tangent, what do we need to prove? B1 is equal to F1. Okay, the tan chord theorem there. How else? B4, yes, is equal to F2. Okay? Or this whole angle is equal to that whole angle. Not so. Alright, but which one are we going to use? B1 is equal to F1. I think that's going to be the easiest one. No? Is that one of the angles you said? Yeah, B1 and F1. If we can do that, the job is done. Not so. But B1 is X. Why is B1 X? It's vertically opposite. Then angle F1 is X as well. Why? Alternate angles. Alternate angles with EF being parallel to GB. So now we said since angle F1 is equal to angle B1, which is equal to X, therefore ABC is a tangent to a circle through EBGF. Why? Why is it a tangent? Angle between line and chord equals angle in the alternate segment. Angle between line and chord equals the angle in the alternate segment. Okay. So now remember, now this is also a tangent to the circle going through that triangle. Okay, I don't want to sketch too much on this diagram. I think I'm just take that triangle out with dots here. Okay, otherwise you could have drawn lightly a circular. Now here I can't draw lightly. So the last question, question C. In C, they're asking us to show that D, or prove that DC is parallel to BG. So if we can prove that that line is parallel to that, I've done the job. Not so? Right. So if you look here, we're going to look at alternate angles being equal. Can you see that?
So it's not BG, right?
Yeah, listen. Is EF not the same as BG? If you can prove that BG, if you can prove that EF is parallel to DC, then it's the same as proving that DC is parallel to BG. Make sense? Okay. Otherwise, here's also alternate angles. No? But we know that D2 is equal to?
Wait, so if they parallel, they're basically the same.
Sorry?
If the lines are parallel, they're basically the same.
Yeah. Because if this line is parallel to that line and that line is parallel to this line, that line has to be parallel to it.
Oh, yeah.
Yeah. People, D2 is equal to which angle? D2, yeah. Isn't it that thing? Why? Equal angles? Angles in the same segment, yes. See, all these lines make you crazy. You're seeing it now. That angle is equal to this angle here. That's all. But this angle here, huh?
Sorry, sir.
Okay, what I'm going to do is I'm just going to put a y here. No? So now I know that this is going to be x plus y. Not so. Then, you see that these are alternate angles. No? So there's your x. So if I can prove this is y, I've done the job. Not so. But is that not y? Because that's going to be the tan chord here and there. Is the job is done? No, not smart. This takes a lot of practice. Okay. Far from smart. So let's go. Let's bring a y into here. Your x before the y. No? So we say let B4 equals y. So if angle B4 is equal to y, then angle D2 is equal to x plus y. Why is D2 x plus y? Because angles in the same segment. Angles in the same segment. And it's coming from arc. Arc CF is subtending that. Okay? So there we go. Then we say that F2 is equal to y. Why is F2 y? Tan chord theta. Alright. So now do you see that that angle is equal to this angle? You see that, people? So we state the obvious. We say since since EFD is equal to D2, which is equal to x plus 1. Not so. Therefore, EF is parallel to DC. Why? Because the alternate angles are equal. Okay? Alternate angles are equal. But have we answered the question? No. Because EF is parallel to DC, therefore it has to also be parallel to BG. And that's the part we are taking. Okay? And there we go. Something like this, people. I'm already seeing 4, 8 and 3. 11 marks. 11 marks. So this is definitely 4 marks. People, that's 8%.
No, it's the one with 8 marks.
Sorry?
It's the one with 8 marks.
How do you mean 8 marks?
If you were like 4.
4. That's 4. 4 on the first question, 4 on the second, and 3 on this. Yeah. Why? Because we have used angles in the same segment. We've used the tan-core theorem already. So there's 1 mark. The second mark is here. And the third mark is concluding properly. Alright. So now you think, people. Right, then I've asked you to do 9.8, not so. The odd numbers, okay? So 9.8, the even numbers I also gave you already. Huh? Right, 9.8, the even numbers. Then 9.9 is the revision exercise. No? Just check if it's 9.9 or just call the revision exercise. That is for Monday. Right, so now you got a whole week now to go through that. Okay, no problem. And I've given you the written out memo, not so? Yes. Did you guys see it? I put it in the group.
Yes.
You're not shaking your head. You didn't open the stuff in the group?
No, I didn't.
Oh, you did. Okay. You all got the memo, no?
Yes.
So what you do is you mark it from there. So there will come a lesson later on sometime with Mr. G, and you tell him what you had problems with. Okay. Yes. This is coming to an end, people. Soon. No, you're going to go to his class. Right. Yeah. Yes. Huh? Yes. As soon as we're done with this, we're going to do this one. So probably by maybe tomorrow. Right, here we go. We are told that TS is a tangent to circle PQVT. PQVT. So if this is a tangent, what do we know? T3 is equal to Q3. Not so. Tan core here. I almost said P. Okay. However, T2 and 3 makes P up. Not so. That's a tan core theorem. Then we are told that, let's leave that one there. Then we are told that VQ is parallel to PT. VQ is parallel to PT. People's lines are parallel, what do we know? Alternate angles are equal. So that is also equal. Not so. Then we are told that PQ and VT produce meet at R. Alright? Then we are told that WQS is a straight line. Q3 is equal to Q5. Q3 is equal to Q5 is equal to X. So all these markings here is also X. Not so. Now the question says, prove that QRST is a cyclic chord. QRST is a cyclic chord. People, how do you prove cyclic chord? Exterior angle is equal to interior opposite. Opposite angle supplementary, and the one we're going to use here, equal angles are obtained by the same chord. As you can see here, here's your butterfly, or your bow tie. There we go. And this is the E. Easy. Why? You alright? Yes, you know what? Yeah. Yes, you in? Yes. Pause alright? Nice. But you guys understand? Who got that one right? Alright, nice. People, listen, if you don't know what to do, just go to what is written down, the memo. Give us some idea. So that later on, we can do the same sum again. There's nothing wrong in doing a write it twice, a geometry practice or problem twice. Nothing wrong. No? Right, so let's go. A. So we're saying that T3 is x. Why is T3 x? Tan chord theorem. Right, so what do we say? Can you see now? That is equal to this there? Yes. So we said since Q5 is equal to T3, which is equal to x. Therefore, QRST is a cyclic quad. Why? Equal angles subtended by same chord. Bang. Equal angles subtended by the same chord. Right. Now remember that this is now a cyclic quad, which means to say what? A circle can be drawn through there. Okay, you guys understand? Take this off, as I need the space so that we keep the diagram in focus. Let's go to B. WQS is a tangent to the circle. W. What is a W? Yeah. WQS is a tangent to the circle PQVT. PQV. Nope. PQVT. That's it. People, if that is a tangent, what do we know? Q1 has to be equal to angle T1. Why? Tan chord theorem. Now we're going to try and prove now that that is the case. Not so. But we know that T1 is equal to what? X. Why? Alternate angles. Can you see that, people? But hang on. Q1 is also equal to X. Why? But hit opposites. I can't believe it's so easy. And why people, man, words? So we said, let's go. Q1 is equal to X. Vertically opposite. Bang. T1 is equal to X. Why? So alternate angles with QS being parallel to PT. Right. So we said, since Q1 is equal to T1, which is equal to X. Therefore, WQS is a tangent to a circle through PQVT. PQVT. VT. Why? Angle between line and chord equals angle in the alternate segment. Yes, Michael? You was answering the question. So remember in English when they say, how old is Peter? Can you say, Peter is 5 years old. No? Comprehension and all that. So now why don't you do the same in maths? Want to write this? Don't be lazy. Right. People see. You won't be penalized. You see, we are nice people. No? And you are nice students. In the right. I've heard this morning that I must keep on encouraging you guys. So maybe for the last couple of lessons I can encourage you. So importantly, you guys can do this. No? Right. SR is parallel to VQ. SR is parallel to VQ. People, if we can prove that SR is parallel to PT, I've done the job. Okay, some reason or other, always go with the other one. And that is how the examiner thinks with this person. They first put you in a predicament other than where you're supposed to. No? Right, so if we can prove that that line is parallel to that line, I've done the job. Not so. So, if you see here, if I can prove that R2 is equal to that angle, I've done the job. Not so. So, T2, if I make this Y, T2 is also equal to which angle? T2 is equal to Q4. Okay, that is why tan cot here. And then the job is done. Why? Because this is already a cyclic quad. Can you see that? So this angle there, which is x plus y, is already equal to x plus y. Oh my word! You still don't see it on the side of the room. Right, let's go again. Act surprised, no? The rest of you again. Let's go again. The question says prove that SR is parallel to QV. So if we say this little one here. Okay. But if we can prove that PT is parallel to RS, then it's the same as saying RS is parallel to QV. And I got alternate angle. So if I can prove that angle, the alternate angle is equal to that alternate angle, then those lines have to be parallel. So what I did was I put a little y there. Then we say, okay, which other angle is y? Q4. Can you see that? So if I can prove this angle is x plus y, the job is done. Because that angle is already x plus y. If that's x plus y, it's alternate and it has to be equal, so the lines has to be parallel. But in the previous question, we have proven that this is a cyclic quad. So if that's a cyclic quad, then there's your bow tie. Can you see that? Which makes this angle equal to that angle, which is x plus y. Which makes that angle and that angle alternate, which is equal. Okay. Right, so let's do that. Let's put that idea to paper now. People, very important, don't mess too much with the diagram. Okay, because you're going to get lost in the exam. Okay, because you guys, okay, I was almost going to say, you guys must not practice. Yeah, you say, I was almost going to say, the old me would have said that. But now, I'm going to rather say that from the sums that you are practicing with, you would have realized that you shouldn't mess too much of the diagram. No? So let's go. So T2 is equal to 1. Why is T2 y? No reason. We said let T2 be 1. So if T2 is y, we see that Q4 is equal to 1. Reason? Tan cot here. Right. Then since that is a cyclic quad, we're saying that, what's that, R2, no? So R2 is x plus y. Reason? Equal angles subtended by the same chord. Okay? So now we say since. Yes? Equal angles subtended by the same chord. Same? Angles in the same side. Absolutely. There's actually the converse there, no? Sorry. You see, that's what happens when I'm praising too much, then I'm thinking of the next praise already. Right? But you are right, absolutely correct. That's angles in same segment, and it's coming from arc TS. No? There's an S here. Right. So since angle PTR is equal to R2, which is equal to x plus 1. Okay? Therefore, PT is parallel to RS, which is parallel to a QV. Why? Because alternate angles are equal. Right? Any confusion here? Right? Like all this sitting with the textbook on your head, the information won't sink in. What are you doing? Okay, listen together. Are you okay? Yeah. Okay, this one here. This was a nice one. The little construction comes into play. For those of you who checked out the memo. So two circles intersect at A and B. We are told that CBD, yeah, is a double chord. CSE and DTE are drawn to meet BA producing E. SA and AT are drawn. Let B1 be X and A4 be Y. The question says, prove that SATE is a cyclic chord. Is a TE is a cyclic chord. So, how do you prove cyclic chords? Exterior angles equal to the interior opposite angle. Not so. So, if we can prove that angle S1 is X, S1 is equal to angle T2. No? We can prove that, we've done the job. Or if we can prove that T1 is equal to S2, we've also done the job. Not so. Alright, so let's see. People, T1 is equal to what? Angle T1 is equal to what? I know you guys did the work, no? But the sounds of it. Okay. T1 is equal to XY. Why is T1 X? Exterior angle of cyclic chord equals the interior angle of interior opposite. Alright. People, but S is also XY. Exterior angle of cyclic chord equals the interior opposite. Is that what you want to say? For this angle here and this angle here? No, not for that one. No. That's not what you're saying, okay?
I'm saying for CBA.
B1, just say B1. How are you then? No? Exterior angles equal to the same. Nice. So we say that S2 is also equal to X. Exterior angle of cyclic chord equals the interior opposite angle. Not so? Now what? Since T1 is equal to S2, which is equal to X. Therefore, SATE is a cyclic chord. Why? The exterior angle equals interior opposite. Okay. So there we go. Cyclic chord. Okay. Next. In the next question, just remember that all cyclic properties are evident. Now they ask you to prove that STDC is STDC. The cyclic one. No? They're the same. STDC. So how we do this? Sorry? Yeah, just it. And then?
You have to prove that ST is equal to C.
Sorry?
You have to prove that STE is equal to C.
STE is equal to?
STE.
Oh, is equal to C. Okay. So angle C is equal to which angle? Sorry? Sorry? Y. Yes? So you say angle C is equal to Y, reason? Exterior angle of cyclic what? Yes?
And then that STE angle is equal to Y because the angle is absolute.
There we go. Can you see that, people? So we say STE is equal to Y, angle in same segment, and it's coming from arc SE. You don't have to write it off, no? So there's your Y. So now we've done the job. So it says STE is equal to angle C, which is equal to 1. Therefore, STDC is a cyclic one. Why? The exterior angle is equal to the interior opposite. Alright, any confusion here? Alright, so for tomorrow's lesson, we're going to wrap up 5, 7, and we'll see what problems you had with the even numbers. Okay? People enjoy the rest of your day? Good morning, class.